Hi there, welcome to Nursing Tutorials with Joel. In today's lesson, we'll be looking at a very important and a strategic lesson, a topic titled Neuroglia, or simply put, glial cells. These are important cells in the nervous system. In a football match, two sets of people exist and are very important to ensure a successful football match. The first set of persons are the main movers of the game, the footballers. The footballers move, they play the game, they do the dribbles and they score the goals. They are the main movers of this game. The second set of people are the regulators, what I call the regulators. For example, you have the referee, the linesman, the coach, the supporters club, another annex group of people that ensure and make sure that the football match is successful. These two sets of people work hand in hand to ensure that we all watch an interesting game and make sure also that the ball is plugged into the net. That brings us to today's lesson, which is about neuroglia, or as I said, glial cells. We'll also be looking at a research that was done on Albert Einstein's brain. We know Albert Einstein was a great inventor. He is a propounder of the theory of relativity. And that theory, in fact, it exists in our everyday life. So many inventions still fall back to the theory of relativity. So we're going to look what was carried out on his brain, what were the results. So after this lesson, we'll be talking about that. Stay with me as we look into today's lesson. Welcome once again. Thank you. Previously, we examined the topic neuron. We saw that the neurons are the main players of the nervous system, just like the football scene. The neurons are the main players. Then we have other cells that support the neurons. They make sure that the neurons are working effectively. These cells are called neuroglia, or we call them the glial cells. The word glia originates from a Greek word called glue, which means to support, to protect. So the neuroglia, they are cells that protect the nervous system. They protect the neurons, they support the neurons, they nourish the neurons. They act as myelin sheets to ensure fast and quick transmission of impulses from one neuron to another. They also play the role of the immune cells in the nervous system. The nervous system, as we know, is a very delicate system where the brain and the spinal cord dwells, coupled with other nerves in the body. There are 6 glial cells in the nervous system, 4 of which are found in the central nervous system and 2 are found in the peripheral nervous system. Now let's consider the ones located in the central nervous system. I'll begin with the astrocytes. Astrocytes are star-shaped cells that are found in the central nervous system, and their work is to protect the neurons. How do they do this? They have foot-like processes that form tight junctions with blood capillaries. This mechanism regulates the inflow and outflow of substances from and to the nervous system, the central nervous system to be specific. The astrocytes are the most abundant in the body, in the nervous system. They are the most abundant glial cells, and they are there to prevent unnecessary substance from entering into the nervous system. For example, neurotoxins, toxic cells, certain drugs won't have access because of the size of their molecules. And these astrocytes form what is called blood-brain barrier. The blood-brain barrier is the mechanism by which the astrocytes regulate what goes in and what comes out. So the astrocyte, it's a very, very, very important glial cell in the central nervous system. Next, we have the ependymal cells. These cells form the lining of the ventricles of the brain and the central canal of the spinal cord. We all know that the ventricles are the portion through which cerebrospinal fluid is produced. The ependymal cells lines these cells and protects the cells. They also aid circulation of the cerebrospinal fluid. The next we have oligodendrocytes. Oligodendrocytes, these are cells that have decreased processes as compared to astrocytes. They have poor number of processes as compared to astrocytes. They also form myelin in the central nervous system. They act as myelin, producing myelin sheets. They wrap the neurons in the central nervous system, thus protecting the neurons in the central nervous system, at the same time promoting the speed or increasing the speed of transmission of signals from one neuron to another. So we've looked at the astrocytes, we've looked at the ependymal cells, we've looked at oligodendrocytes. Let's now look at the microglia. The microglia is also known as the immune cell of the central nervous system. They patrol the central nervous system, searching for cell debris, searching for microorganisms, foreign substances, and they phagocytose such substances and destroy it and digest it within themselves. That's wonderful. So you can say the immune cells of the central nervous system is the microglia. Now let's come to the glial cells that are located in the peripheral nervous system. We have the Schwann cells. These Schwann cells are similar to the oligodendrocytes in the central nervous system. They act as myelin sheets in the peripheral nervous system. So they wrap nerves, they surround these nerves, attach themselves to it to form myelin sheets, and this aids transmission of impulses from one neuron to another. So most nerves are myelinated. When you hear that a nerve is myelinated, a nerve, we're talking of the peripheral nervous system, you should know that a Schwann cell has wrapped it and it's helping its speed of impulses. Next we have the satellite cells. These are small flattened cells that aid in nutrient supply, and also they provide protection to the neurons. So these are the 6 cells that form the glial cells. They aid their contribution. They are the regulators of the game here. They are the supporters club, the referee, the linesman, the coach, and others. They regulate the neurons. They help it to function well. They nourish it and other functions. So now we're going to be looking at a research that was conducted in 1985 by a professor in the University of California named Marianne Diamond. She and her associates, examined the brain, the specimen of Albert Einstein's brain, and shared it into portions and examined it under the microscope to really know if Einstein was carrying a brain like a normal human being, or was carrying the same brain with us. What was so peculiar about him? What made him such a great inventor? to be shocking to discover that the glial cells in his brain were more than normal. Isn't that interesting? The glial cells were so much that they wondered how he had so much glial cells, and with that they came to the fact, or they established the point, that increased glial cells could lead to increased intellect or intellectuality, could increase someone's brilliance, could increase the functions of the brain. And they found this majorly in the left parietal portion of the brain, which is majorly responsible for mathematical function. So meaning that he had so much abundance of neuroglia in the mathematical function portion of his brain, and that helped him. They also discovered that astrocytes were so much, they were more than normal in his brain, and that is why further studies was conducted to find the link between astrocytes and intelligence. Isn't that wonderful? And currently more researches are going on, and in fact they got to discover that what astrocyte does is to help us adapt to new challenges, to new competitions. It helps us adapt to new challenges. So this was what was discovered about Albert Einstein's brain, who was a great inventor of our time. With this, we've come to the end of today's tutorial. Join us next time for another interesting tutorial. I still remain Joel. I'd like you to subscribe to this channel for more educational videos. Thank you, and do have a wonderful day. Thank you.